Hi, I'm Professor David Atlee. In this video, I'll be doing a brief introduction to the Stellarium Lab for Astronomy 141, and then I'll follow that with a detailed walkthrough for how to do the Stellarium Lab using the desktop version of Stellarium to answer all of the relevant questions required to work through the Skylab for Astronomy Lab. Let's get started. First, Stellarium is a free software that simulates the night sky. It's what we call a planetarium simulator because it lets you see how the sky looks at different places on the Earth, at different times of day or different times of year, all from the comfort of your home computer. This is a really powerful tool if you're just learning astronomy because it lets you see how some of the concepts like the ecliptic and the zodiac and circumpolar stars connect over the course of a night, and then how the sky can change over the course of a year. In today's lab, you'll be using this software to do two basic categories of tasks. The first is going to be looking at constellations, and I'll say more about that in the lab itself. So I'll talk to you about what you should be expecting and paying attention to and how to use Stellarium to highlight the constellations once we get to that point of the lab. The other thing that you'll be doing is measuring the positions of stars on the sky. And I'll show you how to do that using Stellarium as well in lots of detail. But before we do that, I want to just introduce and motivate why that might be an important thing to do. Astronomers measure the positions of stars in the sky in a bunch of different ways. The most common system we use that's pretty universal is called right ascension and declination, and it's the sky equivalent of latitude and longitude. Essentially, a given star has the same right ascension and declination, or RA and dec to use the astronomer lingo, no matter who's talking about it. So it's the absolute position of the star in the sky. So if I see a new star go supernova, or I discover a comet, and I want to tell my friend down in Texas, hey, I just found this thing, she can go point her telescope at it just based on those coordinates that I give her. But telescopes are dumb machines, so they're not smart like us. So if we want to tell the telescope where to go to look at that new supernova, it understands like turn this gear 37 clicks to the right. In order to do that, we need to know the position of the star on the sky compared to where we are, because our sky looks different than the sky in Texas, which looks different from the sky in South America. So in order to do that, we're going to use a system called altitude and azimuth. Altitude and azimuth measure the position of a star in the sky for a given observer. So it tells you how high above the horizon a star is, and also how many degrees from due north. Altitude is sometimes also called elevation. You can see that illustrated across the bottom of the slide here. To measure the elevation, you'll start from the horizon and start counting your way up until you get to that star Antares that's been marked. And you'll notice as you start from the horizon and begin working your way up, you'll cross repeated horizontal lines with different elevation degree markings located on the left-hand side of the slide. So we'll start from 0, then we get to 5 degrees, 10 degrees, and eventually we end up between the horizontal lines for 20 degrees and for 25 degrees. So we see that Antares is between those two horizontal lines, and we can estimate that its elevation or its altitude is about 23 degrees. And then we can do the same thing, starting from the left-hand side of the image, to estimate Antares' azimuth. So we'll start from the left-hand side of the slide, and we'll begin repeatedly crossing vertical lines, marking locations that are fixed in azimuth. And we end up between vertical lines of azimuth that are marked plus 170 and plus 175. Now, the degree markings in this particular image are not perfectly visible just because of the way that the display happened to work out for this example, but as we work through the actual measurement in Stellarium itself, those will be more easily visible. Okay, so now that we've talked about how astronomers measure positions of stars on the sky. Let's jump into Stellarium itself and work through the key parts of the lab. All right, I've set up Stellarium for the desktop version, and I've also looked up, prior to beginning, the time of sunset on a random date. I've chosen the random date to be the 17th of May 2020. That's not today, but it will work just fine as an example. The first thing that I'm going to have to do is to check to make sure that I'm in the right location. As you can see, Stellarium thinks that I'm in Paris, and I'm definitely not in Paris. So I'm going to have to change that, and I'll change that by coming over to the left-hand side of the screen here and bringing up the location window in Stellarium. And I'll look up New York City and tell Stellarium that that's where I'm located. Okay, so now it knows that I'm in New York, but I also need to set my date and time because Stellarium currently is using the internal time from my computer, but that's not what I want to be working on. So I'll come over here again to the left-hand side of the display, and this time I'll pull up the date and time display using the button that looks like a clock. And I'll tell Stellarium that today is not October 1st. Instead, it's going to be May 17th. And because I'm interested in having the time of Stellarium set to an hour and a half after sunset, I'll figure out, okay, sunset over here, that's 8:08 p.m. An hour and a half after that is 9:38. So I'll set the internal time to 9:38 p.m. in military time, or 24-hour clock. That's 21:38. Okay, good enough. So now you'll see that Stellarium is telling me it's dark out. I can see the stars, and it's nighttime. Okay, so that's good. And then I'd come over here, and I'd enter in the current time, which is 9:38 p.m. And then I want to find a bright star that's a little bit to the east of due south. So I'm facing due south in Stellarium right now. When I'm facing south, east is going to be not to my right, as it would be if I were facing north, but instead to my left. So a bright star a little bit to the east of due south. Spica there is a good example. So I'm going to be using Spica to work through this exercise. Whoops, okay. The next thing I need to do is I need to bring up my coordinate display, which I'll do by clicking on this bullseye button right here. And that's going to bring up my lines of altitude and azimuth. So I'll just turn where I'm looking a little bit so that Spica is a little bit more easily visible. And then I'll see, okay, Spica is above this line, so it's above plus 35, but it's lower than the next one. And these are steps of 5, so it's below plus 40. And I'm going to look at this and say, that's probably about plus 37 degrees in elevation. So I'll come over here and say 37. And then I'll do the same thing for azimuth. I'll see these azimuth lines across the top of the display. So right now it's between plus 160 and plus 165. So I'll call that 163. It's probably more like 162.5, but good enough is good enough. And that's my example star. And I'm going to come back to Spica at the very end of my lab and repeat this measurement. Okay, so now I'm going to pan around until I'm facing north. So I'll grab my display and just drag it. And then, okay, so there's due north. I'm now facing more or less due north. You'll notice that that is at 0 degrees azimuth. There's plus 335, then 0, plus 5. And then I'm looking for Polaris, so a bright star near 0 degrees azimuth, so near this vertical line right here. I'm guessing it's going to be that. And indeed, that's Polaris. so what is the elevation of Polaris? That's my next question. There's my Polaris right there. It's just above this line, and that's going to be my answer right here. By the way, the positions of stars, their elevations and their azimuth will change, both depending on where you are on the Earth, as well as depending on the time of year. And that's why I've chosen a random day that's not today in order to do this demonstration. No one is likely to be doing this lab on May 17th, pretty much ever. So that's why I picked that random day. It wasn't totally random. But so you should not use my answers to fill in your lab. You should go and figure out the correct answers for yourself for today. Okay, so let me hide those lines of altitude and azimuth. I'm going to hide that grid. And instead, I'm going to bring up the constellation lines and also the constellation names so I can go and try and find some constellations. Okay, so constellation lines, constellation names, but before I do that, I have one last task to perform, because in New York City there's lots of light pollution, and the light pollution makes it really hard to see faint stars. And so we're going to mimic that in Stellarium by changing one of the viewing options for the sky. And I'll do that by coming over here to the View menu. I'm going to turn on the limit magnitude. And then I'm going to change that from 6.5, which is the default, to 4. So by reducing the limit magnitude, I'm basically telling Stellarium I only want to see the brightest stars. Incidentally, if you're doing this using the browser-based version of Stellarium rather than the desktop version, this feature isn't available for you. So you won't be able to set a limit magnitude, but everything else required by the lab, you'll still be able to do. So the exact details of what you're required to find for the browser version are a little different, and this is why. Okay, so now that our sky is properly configured, let's look at some constellations. The first thing that we need to do is to find two constellations, Cassiopeia and Ursa Minor, and to sketch them relative to Polaris. Okay, so there's Polaris right there. It's part of the constellation Ursa Minor. Here's Cassiopeia down here, and then there's the rest of Ursa Minor. So what you need to do for question number 6 is to come over here in this area and to add stars using the draw features or an insert shape tool to place Cassiopeia and Ursa Minor in the appropriate positions. Let me do a really quick demonstration of how that might look. So I'll put in Ursa Minor, but not Cassiopeia. Okay, so I'll come over here and I'm going to insert a shape. Okay, I have to expand that a little bit so the shape tool shows up. There it is. And I'm going to just put in a little circle to represent some stars. So Ursa Minor currently is kind of doing that. So maybe the stars of Ursa Minor should be somewhere right around there. And then you'd make that little W shape of Cassiopeia somewhere down here. Okay, the next question is asking, are the moon or any of the planets visible today? Which ones, and which constellations do they belong to? If you remember, the moon and the planets are going to be found, generally speaking, somewhere near the ecliptic, and the ecliptic generally crosses along the southern horizon. So I'm going to go back south again. I'm going to start looking around and see if I see anything that looks like a planet or a moon. And I'm not really seeing anything that looks like either a planet or a moon, so I must be in the wrong phase of the moon, and I've just picked a weird day. If you're doing this today, which is October 1st, 2020, in fact, there should be a couple of planets visible towards the south, right around the end of twilight. So I won't tell you what they are. Go find them yourself. But let's say there was a planet that was visible. Say Mars was in the constellation of Libra, right here. So I would come over here and I would say Mars is visible in Libra. Libra is part of the zodiac. And then your next job, after you've figured that out, is to just take a tour around the sky and identify a bunch of constellations, 8 exactly, that have at least 3 stars that are visible in your display. If you're doing this in your browser, because you are unable to hide the faint stars, you need to be looking for constellations with at least 5 stars visible. But I'm doing this on the desktop, so I'm looking for constellations with 3. And my friend Libra has 3 visible stars. 1, 2, 3. So if I wanted, I could include Libra in my list. And Libra is part of the zodiac, so I might put a check mark or an X, or basically just any kind of mark next to Libra. Okay. There. That almost looks like a check mark. That's actually a square root sign, but it's good enough. So Libra counts. And I might also include, say, the constellation Hydra, because Hydra has 1, 2, 3, 4, 5, so more than 3. But Hydra is not part of the zodiac, so I wouldn't include my check mark. But then the constellation Crater, right here, Crater only has 1 visible star, hiding behind this E. So that one wouldn't count, and I should not include that one in my list. Other constellations to make sure to avoid, because the question says other constellations, not just any constellations, make sure you don't include Cassiopeia or Ursa Minor, since we've already looked at those. Once you've completely filled out this table, you'll pick one of these constellations, whichever one you like. If you have a favorite constellation, whether that's because you like the way it looks or you like its name, or because you're a Leo and you want to sketch the constellation Leo, whoops, any of those is a good reason, so you can just pick your constellation. And then you'll come down to the last page of the lab and you'll sketch out the way, say, the constellation Leo appears. And as you do that, you're going to make sure that you maintain the relative spacing between the stars, the appropriate shape, and also mark brighter stars with bigger dots. So say the star Denebola right here, or Regulus down here, or Algeba. I don't know this particular star, but so those 3, those are pretty bright. And so you'd want to mark those with bigger marks than, say, this star right here, which is a little fainter, and much bigger than that star right there, which is going to be fainter still. And then once you've done that, you have our next task is going to be a little research project. Don't worry, it's not too hard. You only have to write like a paragraph. Question number 10 is asking you to pick out a particular source within whichever constellation you drew. So Leo, that's my constellation in this example. So I would try to find a famous object in Leo. That could be a bright star, or a black hole, or a radio pulsar, or a nebula, or a galaxy, basically anything you want. But pick a particular object and tell me some information about that specific object, being sure to cite your sources in your answer. The most common problem that students have as they answer this is to talk in general about a category of objects. So don't write about a black hole, don't write about black holes, write about a specific black hole. So say the black hole Sagittarius A star, which is found near the center of the Milky Way. Now that's not in Leo, so that wouldn't count, but if you would happen to draw the constellation Sagittarius, you might use that black hole, and that would be fine. Okay. So once we've finished making our sketch, we'll finish our Stellarium tasks by going back to that star we looked at the beginning and measuring its position again. So I'll go find my friend Spica again, and I'm going to note the current internal time of Stellarium, which is about 21:54, so that's about 9:54 p.m. And then I'll hide my constellations, and bring back my coordinate grid so I can measure its position again. So now, Spica is still above 35, but it's gotten a little bit higher. I might call that more like, call that 37.5. And its azimuth now, whoops. By the way, if you accidentally click on something and you need to make that display bullseye go away, just right click and it'll immediately disappear. Okay, so let's see. There's 180, 175, 170, 165. So I'll call that 167. And then I would note the original position of Spica and then its final position, and I'll see how much it's moved. Okay, so I started out at 37, 163. Now it's 37.5, 167. So did the object move? Yes, it moved. Which direction? All stars move in the same direction, so I'll leave it to you to figure out which direction that was. What's the difference in elevation and also in azimuth? Difference in elevation is 0.5 degrees, and in azimuth, it's 4 degrees. Total motion is, I'm going to figure this out using the Pythagorean theorem. So if you don't remember your Pythagorean theorem, it says a squared plus b squared equals c squared. What we've done is we've measured a triangle. We've measured horizontal motion through azimuth, and we've measured vertical motion through elevation, but what we want is the hypotenuse made by this triangle. So we want to find c. So the total motion is the square root of the change in azimuth, 4 degrees, 4 squared, plus 0.5 squared. And then I would go and do the math. I'm not going to do that right now, but if you'd like to figure out what my answer should be, you can use your calculator and it'll tell you. I'm just going to estimate that. That's going to be just a little bit more than 4 degrees. So I'm just going to call 4 degrees for now. How much time passed between my observations? I started at 9:38 and ended at 9:54. That's a total difference of 16 minutes. Whoops. That's about a quarter of an hour. Therefore, in 1 hour, based on my measurement, I would expect that my star would have moved about 16 degrees. So is that consistent with my expectation of 15? Yes, it is. So I'd say something like, my star moved at a rate of 16 degrees per hour, which is close to the expected rate. And that would be my answer. Your answers to this question will vary. And that's it. So I've worked through all of the relevant pieces. You'll have to spend a little bit more time because I skipped over some of the important details like the sketching of the constellations. But hopefully this gives you enough of an idea of how to use the Stellarium interface and how to approach these important questions that you'll be able to successfully work through the Stellarium Skylab, and also, as you do that, to get a better appreciation for how the night sky looks in New York City right now. Thanks for joining me, and good luck with the lab.